3 things you must do to bring astronauts to the moon, versus what NASA allegedly have done. Here we analyze 3 safety measures against radiation you must accomplish in order to bring a human expedition to the moon. Hopefully in the future someone may achieve it.
Our measurements show that the maximum radiation level as of 1958 is equivalent to between 10 and 100 roentgens per hour, depending on the still undetermined proportion of protons to electrons. Since a human being exposed for 2 days to even 10 roentgens would have only an even chance of survival, the radiation belts obviously present an obstacle to spaceflight. Unless some practical way can be found to shield space travelers against the effects of radiation, manned space rockets can best take off through the radiation-free zone over the poles. In any case, it appears wise to evade the inner zone, and this is not difficult to do so as its latitudinal and radial extent is limited. The outer zone is much more difficult to avoid. There do appear to be cones of escape over the north and south geomagnetic poles. The half angle of these outward opening cones is about 20 degrees. The detailed nature of these cones has not yet been examined by direct observations.
But interestingly enough, all the scientists, and Dr. Van Allen was convinced that we got fried going through his ionosphere belt. This, not the doctors were going nuts, and we want to, as if they couldn't decide whether or not they were going to abort the mission. They didn't have much to say about it, really. Right.
Radiation in space come from?
Actually, it comes in 3 different places when we're in low Earth orbit, like on space shuttle or space station. We have radiation from our trapped radiation belts, the Van Allen belts. We have radiation that comes from outside our solar system called galactic cosmic radiation. We also have radiation that comes from the sun during big solar particle events. Now, the sun has an 11-year cycle that goes from very minimum amounts of activity to very maximum amounts of activity. And during the maximum amounts of activity, we have lots of solar particle events and solar flares, and we can get radiation from those events. Now, when we're going back to the moon and we're outside of the Earth's protected belts, it's going to be much more dangerous for the crews. We can cause acute effects. The crew can get sick very rapidly, unlike they can on space station or space shuttle.
How much time do you have to predict solar flares?
Well, it's actually very difficult to predict space weather. Just as we have a very hard time predicting hurricanes and tornadoes here on Earth, it's very difficult to predict when a solar flare is going to happen. A lot of solar physicists around the world are working on that problem, but right now we don't take action with the crew until we measure an increase in radiation. We are looking at trying to predict when there's an all clear period. That'll allow us perhaps to do an EVA on the surface of the moon when we know there's a 90% chance we won't have a bad solar flare within the next 2 days. Yeah, the sun has an 11-year cycle, and every 11 years it goes from solar minimum, 5.5 years later solar maximum, and then back to solar minimum again. During solar minimum, there are very few sunspots, if any, and thus no solar flares. All the solar flares and solar particle events come out of the sunspots. During solar maximum, we have a lot of activity going on with the sun, and we have a lot of solar particle events. So during solar maximum, we're very active in mission control, trying to keep the crew from getting too much radiation from those events.
My planet needs